dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, selamat petang. Assalamualaikum dan salam sejahtera semua. Apa khabar anak-anak pelajar dan guru-guru yang dikasihi di mana jua anda berada? Kami doakan anda sentiasa berada dalam keadaan yang sihat. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan sekali lagi selamat datang ke Pusat Tuisyen Akademi YouTuber Malaysia. Bermula percuma, selamanya percuma. Jadi petang ini sekali lagi kita akan bersiaran langsung untuk kelas fizik tingkatan 5 dari channel Mr. P, iaitu Cikgu P. Jadi siapa yang belum subscribe lagi channel Mr. P, jom kita subscribe channel Mr. P sekarang dan anda boleh berikan like pada siaran ini. Jangan lupa kongsikan siaran langsung kelas kita pada petang ini kepada rakan-rakan yang lain. Mudah-mudahan lebih ramai lagi akan dapat manfaat daripada apa yang bakal dikongsikan oleh Mr. P sebentar lagi. So petang ini kita akan teruskan kelas kita dengan tajuk 4.3 Transformer dan kelas ini adalah untuk kelas DLP, akan disampaikan dalam bahasa Inggeris dan bahasa Melayu dan yang bukan DLP pun boleh mengikuti kelas ini kerana slide Mr. P adalah dalam Dwibahasa. Betul ya Mr. P?
Ya, Dwibahasa.
Dan kepada semua penonton seperti biasa kami akan kongsikan link sijil ikhlas untuk kelas ini pada penghujung siaran nanti. Jadi anda jangan lupa ikuti dari mula hingga akhir. Baiklah, sebelum kita bermula yang beragama Islam, ayo kita mulakan dengan Ummul Kitab Al-Fatihah. Dan bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi para penonton dan pelajar-pelajar sekalian, okey, so kelas ini akan berlangsung lebih kurang 1 jam dan sekiranya anda ada soalan yang ingin dikemukakan, anda boleh type saja pada ruangan chat ataupun anda boleh respon pada soalan-soalan yang akan dikemukakan oleh Mr. P sebentar lagi. Okey, jadi petang ini saya Cikgu Hasnita dari SMK Bagan Jaya sebagai moderator anda dan presenter kita tidak lain dan tidak bukanlah Cikgu P Kok Hua ataupun lebih dikenali sebagai Mr. P dari Kolej Tingkatan 6 Tun Fatimah Melaka. Okey, jadi cikgu tidak ingin membuang masa. Jadi kalau anda sudah bersedia, ayo sama-sama kita mulakan kelas pada petang ini dengan tajuknya 4.3 Transformer. Okey, silakan Mr. P.
Okay, so thank you Cikgu Hasita. Okay, so saya Mr. P ini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. Okay, so ini merupakan kelas tuition percuma daripada AYU untuk subjek fizik. So sekarang kelas untuk tingkatan 5 kita sudah sampai tajuk 4.2 muatan haba dan kelas tingkatan 4 akan diadakan pada setiap hari Jumaat 9.30 malam. So hari ini kelas tingkatan 5 seperti biasa diadakan pada pukul 2 petang dan saya akan sampaikan tajuk untuk bab 4 dan section 4.3. So hari ini bersama saya adalah Cikgu Hasita. Terima kasih Cikgu Hasita bersama saya pada petang ini. So ini merupakan Panitia Fizik SPM Akademik YouTuber Malaysia. Okay, so I will continue the last subtopic, okay, for chapter 4, electromagnetism. So the subtitle for today will be transformer. So they actually have 4 learning standard for section 4.3. So for the first one will be describe the working principle of a simple transformer. Second will be the describe an ideal transformer. Third will be describe energy loss and way to increase the efficiency of a transformer. And the last will be to communicate about the use of transformer in daily life. Okay, so the learning center one, as mentioned just now, is describe the working principle of a simple transformer. So in our daily life, there are actually many applications of a transformer. In example, here we have the step-down transformer in a mobile phone, chargers, and the step-up transformer in microwave oven. So they are actually more example of the application of transformer in our other electrical appliances. So in this learning standard is actually the extended knowledge for the Form 3, Chapter 6, also known as the electromagnetism. So that means that you actually have already know some of the basic knowledge regarding the simple transformer. So let us go through the first learning standard one, working principle of simple transformer. So this is the definition for the transformer. So transformer is an electrical device which increases or decreases an alternating voltage based on the principle of electromagnetic induction. So for the electromagnetic induction, actually you already learned with Cikgu Hasita at section 4.2. Okay, so at section 4.2, you actually need to know that the electroinduction is actually the production of induced electric current in a conductor which is in a changing magnetic field, or we know as also cut magnetic flux. Okay, so how we can change the magnetic field or cut the magnetic flux? You can look at the figure beside here. Okay, so the induced current will be produced when there is a relative motion between conductor or solenoid and the magnetic field. So the magnetic field represented as the arrow line here. Okay, so when you're moving your conductor, okay, so that means you will be cut the magnetic flux and cause the changing of magnetic field. So the induced current will be produced. But here, there is some different for the mechanism of the simple transformer. So later on, I will discuss with you what is the working principle in the simple transformer. So this is the definition. Okay, so for the structure of transformer, they are actually consist of 2 coins or wire wound around the laminated soft iron core. The soft iron core will be this, okay? And there is 2 coin wire here. Okay, so the first one here we know as the primary coin. So the coin connected to the input voltage represented as symbol VP. Okay, we know as a primary coin. And the coin connected to the output voltage, which is labeled as a symbol VS. So we know as a secondary coin. So the basic structure here is the transformer consists of a laminated soft iron core together with the 2 coins of wire, which is known as a primary coin, here labeled as VP, and the secondary coin will be VS here. Okay, and then the symbol you also already learned at Form 3, Chapter 6. Okay, so this is a symbol. This is a symbol for the transformer. Okay, so let us discuss together the working principle for transformer. So firstly, when an AC voltage, AC represented as alternating current, okay, so here will be VP, is supplied to primary coin, so will be here lah. And alternating current IP flow to the coin, so the IP will be here. The soft iron core is magnetized. So as we know that when the current flow to a conductor, so the temporary magnetic field will be produced. So that means here also will be the same, which is known as the magnetized. Okay, so the magnetic field produced varies in magnitude and direction. The secondary coin cut the magnetic flux of primary coin. The changing magnetic flux causes the induced EMF to pass through the secondary coin. The spelling will be like this now. Okay, so here that means that you can see because of the different numbers of coin in primary and secondary, so this causes the magnetic field changes in terms of magnitude also together with direction. So, and the induced EMF will be produced at the secondary coin. Okay, so the induced current will be flow through the secondary coin, so will be IS lah. Okay, so this is the working principle for transformer. Okay. Okay, so number 4, there are 2 types of transformer, which is the step-up transformer and step-down transformer. So here you can see the step-up transformer, the primary coin here will be less than the numbers of turn of secondary coin here. Okay, so a step-up transformer has more turn of wire on secondary coin, which make a larger induced voltage in the secondary coin. So you can look at this symbol. So the numbers of turn in primary coin will be less than numbers of turn at secondary coin. So this will make the output voltage, okay, which is also known as the voltage in secondary coin, larger than the primary coin or input voltage. Okay, so it is called a step-up transformer because the output voltage larger than the input voltage. Okay, so you can look at this symbol. So the output voltage Vs is larger than input voltage Vp here. Okay, so for the step-down transformer will be vice versa. Okay, so here you can look at this figure. The numbers of turn at primary coin will be more than the numbers of turn in secondary coin. A step-down transformer has more turn of wire on primary, so as mentioned already, and less turn of wire on secondary coin. Therefore, you can look at this symbol. The input voltage will be larger than output voltage. Okay, so this makes a smaller induced voltage in the secondary coin. So that means at here you can see if the numbers of turn greater, so the voltage will be higher. Okay, so this will be meet the Faraday law. So where the Faraday law state that the voltage is directly proportional to the numbers of turn in the coin. Okay, so you can see the relationship here, V directly proportional to N, and the equation here, V equal to Kn, so K will be the constant lah. So we can change become like this lah. So that means here will be NP over Vp equal to Ns over Vs lah. Okay, so the NP represent as the numbers of turn in primary coin, so will be here. Okay, then the Vp represented as the primary input voltage, so will be here. And Ns here will be numbers of turn at secondary coin, so will be here. And the Vp will be output voltage, here mentioned as secondary output voltage, so will be here. Okay, so here you can see we have others parameter here. The IP will be represented as the current in primary coin. Okay, so when as mentioned just now for the working principle, when the input voltage is connected, so there will be a current flow through the primary coil. Okay, and then here we have the line of the magnetic flux linking primary and secondary winding. So as mentioned just now, due to the soft iron core magnetized, okay, and cause the changing of magnetic field in secondary coil, so they will produce induced EMF, and then the induced current will be flow through the secondary coil. So the current here, IS represented as the current in secondary coil. Okay, so this formula will be used in this section. So let us look together the question number 1. So diagram shows a symbol of transformer. The function of this transformer is to increase. So what is the function of this transformer here? So if you observe the numbers of turns at primary coil and secondary coil, so you can see that the primary coil will be, the numbers of turns at primary coil will be less than the numbers of turns in the secondary coil. So here will be the step-out transformer. Okay, so here you can see, as mentioned, the numbers of turns at primary coil will be less than the numbers of turns in secondary coil. So this is known as a step-out transformer. And secondly, we already learned that the definition for transformer is used to increase or decrease the alternating voltage based on the principle of electromagnetic induction. So here will be increase or decrease of the voltage. So the voltage is also known as the potential difference. So you can look at the answer here. A, the output energy will be increased. So we wrong because we want to get the answer where is related to voltage. So the B also not the answer because of the power. C is current. So the potential difference here is actually referring to voltage. So the answer here will be D. Okay, and then the question number 2 is also one of the question at 2019. Okay, section A. Okay, so let us read the question together. So a charger adapter, so we here. Okay, charger adapter is a device which has a step-down transformer as one of the components. Diagram 6.1 shows the charger of laptop and the specification of the step-down transformer. So here will be the step-down transformer for the charger, okay, for a laptop. And then for the diagram 6.2 shows the charger of an electric toy car and the specification of its step-down transformer. So this is the adapter, okay, adapter for the toy car. So they mean both of the diagram here is the same transformer, which is a step-down transformer. Okay, so and then here we have the specification. Okay, so we see together what's the question going to ask. Okay, so the first, what is the meanings of the step-down transformer? So as per mentioned just now, for transformer, we will discuss the voltage. Okay, so the answer here will be a transformer which lowers the input voltage. So that means the output voltage will be smaller. So you can mention lower the input voltage, or you can give as the output voltage produced smaller. Okay, for the definition. Okay, then the second, explain how the output voltage is produced by the transformer. So the output voltage here is referring to the voltage at secondary coil. Okay, so as mentioned, so the first we need to discuss the changing of magnetic flux, and then the induced EMF will be produced. Okay, so the first mark here will be the secondary coil cut the magnetic flux of primary coin, or you can mention changing magnetic flux in secondary coin. Okay, so this will induce the EMF to pass through the secondary coin. So the induced EMF here referring to the output voltage lah. Okay, so this is the two reference answer, okay, for this question. Okay, so the next C. So observe diagram 6.1 and 6.2 and compare input voltage. Okay, so here you can refer the specification for diagram 6.1 and 6.2. Okay, and you have to find out where is the input voltage. So from here, you can see at diagram 6.1, the input voltage VP here will be 240 volt. And the input voltage for diagram 6.2, the charger for electric point here will be also 240 volt. So this is very clear that the answer will be same lah. Okay? Okay, so the second, so will be comparison between the output voltage. So again, referring to the specification at the diagram 6.1 and 6.2. So will be at the purple color box here. So at the diagram 6.1, the VS or the output voltage will be 19, while for the diagram 6.2 will be 6. So this is very clear that the output voltage at diagram 6.1 is greater than diagram 6.2. Okay, so you just need to give the simple answer as this lah. Okay, so diagram 6.1 greater than 6.2. Okay, and then the third will be comparison between the numbers of turn of secondary coin. Okay, so again, you have to referring to the specification given at the diagram 6.1 and 6.2. Okay, so will be at here. So which is the green color box here. So the numbers of turn of secondary coin, okay, which is stated as a symbol NS. So very clear. So it's 119 for diagram 6.1, and the diagram 6.2 will be 60. So again, you can see the numbers of turn of secondary coin for diagram 6.1 will be greater than diagram 6.2. So you can also give the simple answer like this lah. Okay, so this is the very, very easy question actually if you know the technique to answer. Okay, if you not read anything, if you know the technique to answer, you can get full marks for conception question here. Okay, so the next question 4, the ratio of the numbers of primary coin to the numbers of secondary coin. So will be MP over NS. So again, referring to the specification given, so be represented as the red box here. Okay, so for diagram 6.1, the ratio will be 12.6, and the ratio for diagram 6.2 will be 40. Okay, so that means that the ratio MP to NS will be less than 6.2 lah. Okay, we compare these two values here. Okay, so you just mentioned diagram 6.1 smaller than 6.2. Okay, it's quite straightforward question. Okay, for this past year question. Okay, then the last D, based on your answer in C, state the relationship between the MP to NS and the output voltage. So that means you need to state the relationship between this MP to NS ratio and the output voltage. So it will be purple color box here lah. Okay, so you can compare. Okay, we just now already compared the ratio MP to NS at diagram 6.1 and the diagram 6.2. So you can see the diagram 6.1 will be lower compared to 6.2. So how about the output voltage? So the output voltage at the diagram 6.1 is 19, and the value for diagram 6.2 will be 6. So that means the diagram 6.1 will be greater lah. So that means the relationship will be the ratio MP to NS lower, the output voltage will be higher lah. Okay, so you can just compare one of the figure. Okay, so the answer here, when ratio MP to NS decreases, if we referring to diagram 6.1, the output voltage will be increases. Okay, if you referring to diagram 6.2, so here you can see 40 and 12.6 here will be greater. For the output voltage, 19 and 6 will be lower. So you can mention as when ratio MP to NS increases, the output voltage decreases. Okay, so this answer will be also accepted. So it's very straightforward question. Okay, so we have already finished our learning standard 1. So we go to our learning standard 2, which is describe an ideal transformer. Okay, so what is the ideal transformer here? Okay, so in an ideal transformer, there is no power loss. Therefore, all the power supply to the primary coil will be transferred to secondary coil. So that means the power will be 100% transfer from primary coil to secondary coil. Okay, so efficiency of the transformer with this symbol, okay, will be like this: output power over input power times 100%. So in the real application, there is no any electrical appliance, okay, can be no power loss. Okay, so that means if we want to know the efficiency of the electrical appliance, so we can use this formula lah. We have to know the output voltage, okay, and then divide with the input voltage, output power divided by input power and multiply with 100%. Okay, so later on we have the example for this application of the formula. Okay, so the second, for ideal transformer, no energy loss occurs. So that means the efficiency will be 100%. Okay, therefore, the input power in the primary coil will be equal to the output power in secondary coil. Okay, so we have already learned this equation. P equal to VI, V referring to voltage, I referring to the current. Okay, so we know that the input power will be Vp. Okay, voltage for input and the current for input also equal to the output voltage multiplied with the output current. Okay, so from here, if we rearrange the formula, okay, so that means we remove the Vp to another side, okay, and we remove the Is to another side. So that means we get this formula lah. So this is the relationship between I and V lah. Okay, so this also you have to remember, okay? Okay, so for the checkpoint 4.3, question number 3. Okay, so diagram shows an ideal transformer used to charge a laptop. Okay, so from here, you can see the primary coil, the numbers of turn of wire here is more than the secondary coil. So from here, we know that this is a step down transformer here. Okay, so what is the current in the primary coil? Okay, as the question given you already, this is the ideal transformer. So that means the input power and the output power will be the same. Okay, so in the question here, how we know there is the power? So we can referring to the unit. So the W is a unit for the watt, okay, which is the unit for power. So we know that this is the output power. So which will be equal also for input power, since this is the ideal transformer. Okay, so that means the output power and input power here will be 90. Okay, and then the another information here, the question given us the input voltage here will be 240. Okay, so and we have already known that the power equation will be equal to V over I. Okay, and the question already given us the power equal to 90. So which will be equal also for input power lah. And the input voltage here will be 240. So we substitute to the equation and rearrange. So we get the I, which is the current in the primary coil, will be 0.375. Okay, so the answer here will be B lah. Okay, so the next question, question number 4. Okay, so the efficiency of the component in box X is 80%. So that means this is application for the efficiency of the electrical appliance formula just now. Okay, so calculate the input current when the output power is 65. So the output power here, which is mentioned here, is 65 watt, is power which will be less than input power, which we expected because the efficiency here is 80, is not 100. Okay, so the efficiency given here is 80% and the output power here is 65. So that means we apply this formula. We substitute efficiency here as 80% and the output power here is 65. And we get the input power will be 81.25 watt here. Okay, and we have to calculate the input current. So the relationship between current, power, and voltage will be P equal to VI lah. Okay, just now we already used this formula. We substitute the power as 81.25. Then the voltage given here for the primary will be 240. So that means the input current will be equal to 0.34 ampere. Okay, so make sure your answer in at least 2 decimal places and correct unit. Okay, so this is the answer. Okay, so Cikgu Hasita, we can maybe take a break first.
Okay, students, kita berehat sebentar, jangan ke mana-mana, kembali seketika nanti bersama dengan topik yang seterusnya.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okey, kepada pelajar-pelajar yang baru saja mengikuti kelas ini, selamat datang cikgu ucapkan. Anda kini mengikuti kelas fizik tingkatan 5 secara langsung dari channel YouTube Cikgu P ataupun lebih dikenali sebagai Mr. P. Jadi siapa yang belum subscribe Mr. P lagi, anda bolehlah tekan butang subscribe di bawah dan jangan lupa tekankan loceng notification for all supaya anda akan menjadi orang yang pertama mendapat notification apabila Mr. P mengadakan kelas secara live ataupun muat naik video-video fizik yang baru. Okey, jadi kita teruskan bersama dengan Mr. P. Silakan Mr. P.
Okay, thank you Cikgu Hasita. Okay, so we have already go to our third learning standard. Okay, so the learning standard 3 for today's subtopic will be describe energy loss and the way to increase the efficiency of a transformer. Okay, so in this subtopic, okay, and the learning center 3, you have to know what is the cost of the energy loss in the transformer. So here we have 4 costs, okay, 4 causes the energy loss of the transformer. Okay, so the first will be the resistance of the coin. So energy is lost as a heat in the coin because of this formula you can see. So here the energy loss is due to the resistance of the coin, and the loss will be in the terms of the heat. Okay, so you like say the question asking you what is the energy loss of the transformer? So you have to know the current flow through the transformer and the resistance of the coin and the time you want to know, okay, the loss. Okay, so the equation here is actually you already learned at the chapter 3, okay, so which you apply these 3 formula, V equal to IR, P equal to VI, and P equal to E over T, okay, and then we rearrange all, and then we get this formula. And the question maybe will ask you regarding the energy loss and also the power loss, okay. Okay, so how we can overcome the energy loss due to the resistance of the coin? Okay, so here you can using a thicker wire which is made out of the good conductor. For example, the commonly we use will be the copper, okay, as our coin wire here. Okay, so the reason, okay, because the thicker wire or the good conductor, okay, can reduce the resistance of the coin. Okay. Okay, the second cause of the energy loss in the transformer will be the eddy current in the core. Okay. Okay, so you can look at this figure. So this is a core, okay, of the transformer. Okay, and then you can see there is the eddy current, okay, produced in the core here. Okay, so how this will be happen? So you can look at here. The changing magnetic field causes the electron in the soft iron core to circulate around. Okay, so the flow of electron is actually the current. Okay, so the changing of magnetic field here will cause the electron circulate around and produce the eddy current in the core. Okay, so the eddy current will be lost as the heat. So that means they will be also same as the coin of the resistance of the coin. So will be also lost as the heat. Okay, so how we can reduce the eddy current in the core? Okay, so we can using the laminated core. So the laminated core will be like this. There is a lot of the thin sheet, okay? So they will be combined together with the insulator. So example, glue, okay? So here, make up of thin iron sheet glued together with thin layer of insulation. Okay, so it will be reduce the eddy current, okay, because the eddy current is not able to flow through the layer of insulation. So you can see here, this is an example. So the thin sheet will be glued up, okay, and the glue is actually the insulator, so which will be not allow the eddy current flow through this at the core of the transformer, okay. So therefore the eddy current will be reduced if you're using the laminated core. Okay, so the third cause will be the hysteresis effect. Okay, so what is the hysteresis effect? So the energy loss in the process of magnetize and demagnetize the iron core each time the current changes is direction, changing its direction is known as the hysteresis loss. So that means when we give the voltage, okay, the current flow through the iron core, so it will be magnetized. And if let's say we off the power supply, so the iron core will be demagnetized again. Okay, so when we on and off, the iron core will be magnetized and demagnetized. So, and repeating of this process will cause the loss of energy. And this type of loss will be known as the hysteresis loss. Okay, so the energy loss in the form of heat that heat up the core, iron core. So that means the loss here will be also referring to the heat loss. Okay. Okay, so how we overcome this problem? So we can using a soft iron core. Okay. Okay, so the reason, because the soft iron core can be magnetized and demagnetized easily. Okay, so the core require little energy to be magnetized and demagnetized and decrease the hysteresis loss. Okay, so the last cause in our discussion will be the leakage of the magnetic flux. So electrical energy is lost due to the loss a part of the magnetic flux in the primary coil. Some magnetic flux result from the primary coil that do not pass through the secondary coil. So that means the magnetic flux from the primary, okay, is not able to pass through the secondary coil, maybe due to the distance here. Okay, so causing induced EMF in the secondary coil becomes smaller because we have the loss. So the product or the output voltage will be smaller than expected. Okay, so how we overcome this problem? Okay, so here this is the design of the core. Okay, we know as a shell type. Okay, the normally type will be like this. Okay, so this is we know as the core type. So from here you can see the core type, the primary coin here and the secondary coin will be separate, far apart. Okay, so to avoid or to reduce the magnetic flux leakage, so we can bring the secondary coin and the primary coin more closer. So at here you can see the secondary coin is widening on the top of the primary coin. So the purpose here is we want to reduce the distance between the secondary coin and the primary coin so that the leakage of the magnetic flux can be reduced. Okay. Okay, so widening the secondary coin on the top of the primary coin will be like this. This is known as the shelf type. Okay. So that we can reduce the distance between the primary coin and the secondary coin. Therefore, the leakage of the magnetic flux can be reduced by widening the secondary coin on top of the primary coin. Okay, so this is the 4 causes of the energy loss in the transformer and the way we overcome and how the way we overcome can solve the problem, which is reducing the energy loss in the transformer. Okay, so here is the use of the induction cooker. Okay, so just now we mentioned that the eddy current will cause the power loss or energy loss in the transformer, but actually we also can use the eddy current in the induction cooker. Okay, why? Because the eddy current can produce a heat which can be used to heat up our food. Okay. Okay, so here an induction cooker make use of eddy current to cook food. When an induction cooker is turned on, an alternating current flow through the coin below. So here you can see below the top plate. So the top plate will be here. Okay, so the current flow will be at the coin lah. So the current produce a changing magnetic field which induce eddy current in the metal utensil. So that means here we purposely want to produce the eddy current, okay, which will be different with the, we want to overcome the power or energy loss in the transformer. And here we want to produce more eddy current. So that means here, the core here will be, we do not use the laminated iron core, okay? We want to using the compact core, okay, which will produce more eddy current and produce more heat, okay? Okay, so the eddy current heat up the utensil, which in turn heat up the food in the contents, okay? So this is the application of the eddy current, okay, in the induction cooker. Okay, so for the question number 5, for this subtopic is from the past year question now, okay, 2015. Okay, so diagram shows the low efficiency of the transformer. Okay, so here is a transformer. Okay, so the statement given here with the low efficiency transformer. So you are required to modify the transformer in the diagram so that the efficiency of the transformer increase. State and explain the modification based on the following aspect. Okay, so here you have to discuss the type of the material used for the wire, diameter of wire, type of the material core, characteristic of the core, and the distance between the primary coin and the secondary coin. So that means this question is exactly what we discussed just now. Okay, so and this is a 10-mark question at section B in 2015. So that means here will be the section C for our current KSSM format lah. Okay. Okay, so the first we have to discuss the type of the material. Just now we mentioned already we're using the copper because the copper have the lower resistance. Okay, so that means we choose copper wire here. Reason, copper wire has lower resistance. And then the second, we'll choose bigger diameter lah. Okay, because the bigger diameter also have a lower resistance. Okay, so bigger diameter of wire, okay, because the bigger diameter of wire will be smaller resistance. And the third one, type of the material of the core. So as per mentioned just now, we're using the soft iron core because it can be magnetized and demagnetized more easily lah. Okay, so easy to magnetize and demagnetize. The fourth one, characteristic of the core. So here use insulated and thin soft iron plate. So that means this is actually referring to the laminated core lah. So the thin sheet of the core will be glued together, okay, with insulator. So will be reduce the eddy current produced lah. Okay, as per mentioned just now, the eddy current not able to flow through the insulator layer between the thin sheet lah. Okay, so here is to reduce the eddy current. Then the last will be the distance between the primary coin and the secondary coin. So definitely will be we need to have the closer distance between the primary coin and the secondary coin. As per mentioned just now, we're using the design of the core will be sharp type. Okay, so where the secondary coin will be widening on top of the primary coin. Okay, so we want to reduce the leakage of the flux lah. Okay, so here distance between primary coin and the secondary coin, must be closer. Okay, so the BM will be jarak antara gegelong primer dan gegelong sekunder lebih dekat. Okay, so here lebih dekat BM, I give the answer here already. So for English will be must be closer lah. Okay, okay, so will be like the shell type of the core. so to reduce the flux leakage lah. Okay, so this is a question for learning standard 3. Okay, so we go to our last learning standard 4, okay, which is about the communicate the use of the transformer in daily life. Okay, so here we'll discuss 2 applications. Okay, the first will be the charging mobile phone. Okay, so here this is the charger. Okay, we apply every day. Okay, I think. Okay. So the power supply, okay, for the charger will be 240 volt lah. Okay, this is for Malaysia lah. So our power supply will be 240 volt. Okay, so will be here lah. So this is a mobile phone circuit. Okay, so you can see a transformer is here lah. Okay, so the input power will be 240 volt. Okay, and then here you can see the output voltage here will be 5 volt. Okay, so the output voltage of the charger will be 5 volt for this mobile phone charger circuit lah. Okay. Okay, so main source of the electrical supply is 240 volt. However, the mobile phone only needs 5 volt of the electrical energy to charge. In this situation, we need to have a step-down transformer. Okay, so a step-down transformer must be placed on the adapter so that the mobile phone gain enough electricity. Okay, so this is one of the application of the transformer in our daily life lah. Okay, so the second will be the electricity transmission system. This one actually you already learned at your PT3, Form 3, Chapter 6, and the discussion at Form 3 is actually more detailed than the Form 5 here. Okay, but the Form 5 here is more discussion on the formula applied at the energy loss or power loss lah. Okay, so during the transmission of electricity from the power plant to industry, office and household, there is always a power loss in terms of heat. Okay, so the power loss, we're using this formula, I square R. Okay, I will be current, R will be resistance. Okay, so due to the resistance in the transmission cable. So there are 2 ways to minimize the power loss. So the first, use the thicker cable to reduce the resistance of the cable. So this formula you also already learned at Chapter 3 lah. Okay, so the relationship between the resistance to, this one is resistivity of the material. L will be referring to the length of material and length of the wire. Okay, and then A will be the cross-sectional area for the wire lah. Okay, so that means here we actually want to increase the cross-sectional area. So you can see when air increase, the resistance will be decreased lah. Okay, so this formula will be, you can see at chapter 2, at chapter 3 at electricity, okay, for the detail lah. So however, the thicker cable increase the weight of the cable and construction cost. So that means, although the thicker cable, as we discussed just now, can reduce the resistance lah, okay, because we can increase the current flow. However, the thicker cable will be heavier lah, and the cost will be increased. Okay, so for B, transmission of electrical power at high voltage so that the current flowing through the cable is lower. So this one actually you already know at Form 3. So how we can reduce the power loss? We can increase the voltage, okay, by reducing the current flow, okay? When the current flow through the cable reduce, the heat loss will be also reduced lah. Thus, the power loss is lower as the power loss. Okay, so here the extended knowledge for Form 5 here is actually application for this formula lah. Okay, I squared out, and the formula here is actually also discussed at chapter electricity already. Okay, so this can easily be done by using a step-up transformer. Okay, so that means in the electricity transmission system, we're using step-up transformer to increase the voltage, okay, so that the current flow to the cable will be reduced and the power loss will be reduced, okay, because the power loss in the heat energy will be reduced. Okay, so basically this is transmission electricity happens in daily life. Okay, so here is actually the short route already. So for the Form 3.1, there is more. Okay, so basically here you can see there are two transformers here. So the first will be the step-up transformer. So the power produced by the power plant is normally 25 kilowatt. Okay, so they will be increase the voltage so that the current flow will be reduced and the heat loss will be reduced. So that means the power loss will be reduced when we increase the voltage, when we transmitting the electricity. Okay, and then when we reach to the house, okay, example house, we only using 240 volt. Okay, so that means we need to have the step down transformer. Okay, so that means in the electricity transmission, we're using the step up transformer at the beginning, and then we're using a step down transformer at the end. Okay, so electricity produced in power plant is stepped up by the step up transformer. So over here. Okay, and then high voltage electricity is transmitted through the transmission cable. So here will be the transmission cable. So the step down transformer then step down. Okay, here also got step down. Okay, step down, then step down the voltage to the suitable value for use. For household will be 240 volt. Okay, so we go to the question 6. Okay, so this is a question in 2016. So diagram shows a handphone and its charger. So which pair is correct about the transformer in the charger? So here we have to choose type of the transformer and the characteristic. Okay, so here, firstly, you have to see the input voltage will be 240 volt and the output will be 5.3 volt. So that means here, there will be the step down transformer. Okay, so here, step down transformer will be only A and C. Okay, and then for the step down transformer, the secondary coin will be less than the numbers of turn at primary coin. And the second will be the output voltage will be lower than the input voltage. Okay, so first we will select A and C, B and D will be up. Then the second, from our statement here, so we will choose NS less than the MP. So answer will be C. Okay, then the next question, second last one, we had 8 questions actually. So electric power is transmitted from a power station to a town via transmission cable with a total resistance of 50 ohms. Okay. If the power station generates 2,200 kilovolt of power, calculate the power loss in the cable if the voltage transmission is at 11 kilovolt and 400 kilovolt. So firstly, we have to count the power loss for the 11 kilovolt. Okay, so the question given us power 240 kilowatt and the resistance is 50, and the voltage will be 11 kilovolt. Okay, so we're using this formula, P equal to VI. So we arrange, we get the current will be 20 ampere. And the next, just now I mentioned already, the power loss formula we're using I square R. Okay, so we substitute 20 in I and the R with 50. So we get 20 kilowatt. Okay, for the second, which have the higher value of the voltage. Okay, so we expected with the high voltage, the power loss will be reduced. Okay, so again, these three information given by question, and then we're using the same formula, and we substitute 220 kilowatt. So have to change to SI unit lah. Just now also the same. We change the 220 kilowatt to 220,000 watt lah. And the voltage for first question 11 kilowatt will be 11,000. So here the 400K will be changed to 400,000 lah. So we get the current 0.55 ampere. Okay, and we substitute again in the same formula. Okay, we get the power loss will be 15.125, which is less than the first question here. Okay, so here you can see when the voltage increase, the current flow will be reduced. So that means the heat loss will be reduced. So the power will be also reduced. Okay. Okay, so the conclusion here, what is the conclusion based on the answer A1 and A2? So as per mentioned, just now you can see, this is the answer just now we already did. Okay. So here you can compare the voltage. So here 11 kV have a low voltage and the 400 kV will be higher lah. And then we compare the power loss. So you can see with the lower voltage, the power loss will be greater. While on the other hand, with the higher voltage, the power loss will be lesser lah. Okay, so here the power loss in the cable is greatly reduced by transmitting the power at a high voltage. So that's why we need to have a step-up transformer to step up the power generated at power generator. Okay, so that the current will be transmitted with high voltage, which will be reduce the heat loss, and then definitely will be the power loss decrease lah. Okay, so our last question, okay, will be also a past year question in 2017, okay, regarding the decision-making question. Okay, so diagram show how electricity is transmitted from power station to school. So power station will be here, the school will be here. Okay, by using the cable and transformer. Okay, if we apply the knowledge we learned just now, okay, so the X will be the step-out transformer, which will be increase the voltage generated, the voltage generated by the power station, so that the current flow will be reduced, okay, and the power loss will be reduced now. And go to the Y, we have to step down the voltage, okay, because the voltage needed for the school will be lower than what already increased at the transmission cable lah. Okay, so step one, characteristic of the material that is used to make the transmission cable. So just now we know already we're using the copper wire because it has the lower resistance. Okay, so here we need to have the character, not type of the material. Okay, you must be very careful here. So the answer here will be low resistance. If you put copper wire, it will be wrong because the question here asks you to give the character, but not the type of material. Okay, so the next, the output power and the output voltage at the transmission cable will be 10 megawatt and 132 kilovolt respectively. The total resistance of transmission cable is 600 ohm. Okay, so the question asks you to find out the value flow through the cable. Okay, so here the question gives us power, give us voltage, give us resistance. Okay, and then we need to find out the I. 2 marks here. Okay, so as mentioned, these two values is given. So make sure you change to the unit SI lah. Okay, what? Here volt. Okay, using this formula, P equal to PI. P will be 10 times 10 power 6 lah. And then the volt will be here. 132 times 10 power 3. So we rearrange the formula, we get I equal to 75.76 ampere lah. Okay, again, make sure 2 decimal places with correct unit. Okay, and the next question here, we need to calculate the power loss in the cable. So as mentioned, we're using one formula, I square R. I already able to get from the answer in question 1 here, which is 75.76, and the R is 600 given by the question. Okay, so we just substitute to this formula. I square R, you get your answer is 3.44 times 10 power 6 watt. Okay, it's quite straightforward question. Okay, so this is the decision making question, normally at question number 8. Okay, so in the school laboratory, a step down transformer used to light up a 12-volt bulb. PQR are 3 different step down transformers. So here we have 3 types of transformer. Okay, to step down the voltage from 240 volt, which is the voltage from the plug, okay, for the power supply. Okay, and the bulb have the power rating, which is 12 volt. Okay, so the table 2 show the characteristic of those transformer. So here we have the material. You want to choose iron or soft iron. And then we have the shape of the core and the ratio of MP to NS. Okay, so based on table 2, state the suitable characteristic of the transformer which can light up the bulb with normal brightness and least energy loss. So that means you have to choose which one will be give the normal brightness. So the normal brightness here referring to the bulb have to at least 12 volt. Okay, and this energy loss, we have to choose the best material and the shape here. Okay, so the ratio will be referring to the normal brightness. Okay, which is the output voltage must be 12. Okay, so based on the question 1, material, you have to choose the material of the core and reason. So it will be here. So we have 2 options, iron or soft iron. As per explanation at our learning center 3, definitely we'll choose soft iron. Okay, because it can be magnetized and demagnetized easily. Okay, so can be magnetized and demagnetized easily. Then the next will be the shape. So here we have 2, X and Y. So as per mentioned, the X will be the shell type and the Y will be the core type. So the R will be have the same type, so will be X here. Okay, so we have to choose the shell type, right? So which is the shape X. Okay, because the distance between the secondary coin and the primary coin will be closer, so that the flux leakage will be able to reduce. Okay, so we will choose X. Reason, leakage of the magnetic flux can be reduced by widening the secondary coin on top of the primary coin. Actually, you can just mention leakage of magnetic flux can be reduced. Okay. Okay, so the ratio MP to NS. Okay, so as per mentioned just now, okay, we have to refer which will be the correct ratio here. Okay, so at the normal brightness, we have to choose the transformer which can give the step down value of voltage from 240 volt to 12 volt. Okay, so the first one definitely we already because we need to have the step down transformer. So here you can see the P, the NS, the turn is small. So that means this one will be the step out transformer. So the P is out already. So we have to choose the ratio for Q or S. Okay, so here we're using the formula we learned at Learning Center 1. Okay, so we apply the numbers of turn. 240. This one is VP. VP is 240 volt. Is the power supply voltage. And then the Vs is the normal brightness voltage needed for the bulb, which is 12. So we get the ratio will be 20 to 1 for the MP to over NS. Okay, so that means it will be R. Okay, so we will choose the ratio will be 20 to 1. Reason, because the MP to NS ratio will be this. Okay, if you show the calculation, I think this will be also accepted. Okay. Okay, so choose the more suitable transformer. Okay, just now we mentioned already, we will choose the material soft iron core. Then we have to choose the shape will be X. So the answer here will be R. Okay. Okay, so that's all for my discussion today. Okay, thank you. So I pass back to Cikgu Hasita.
Okay, thank you very much Mr. Pei. Terima kasih kepada semua pelajar yang telah menunjukkan respon yang baik. So we have T-Bash on the line, Mr. Pei with us.
Hey,
So
sorry.
T-Bash, yeah. Dan kita juga ada tadi Anis Nazira and QR, dan I believe there's a lot more who's joining our class. So thank you very much for your time and your effort. Cikgu nak ucapkan berbanyak-banyak terima kasih di atas usaha dan masa yang anda luangkan pada petang ini. So mudah-mudahan apa yang dikongsikan oleh Mr. Pei tadi sedikit sebanyak dapat membantu anda untuk faham tajuk transformer ini dengan lebih baik. Kerana sebenarnya anda telah pelajari semasa tingkatan 3 dahulu dalam bab 6, dan kita sebagai as a repetition lah for today. Dan lebih banyak maklumat yang lebih detail. Okey, jadi dengan ini sekian saja kelas kita pada hari ini. Sebelum itu cikgu kongsikan dahulu link sijil untuk kelas pada hari ini. Telah cikgu kongsikan pautannya. So anda boleh isikan link sijil ini menggunakan email MOE ataupun email delima anda, ataupun boleh juga menggunakan email Jawi ataupun MyGuru. Dan anda boleh isikan dalam tempoh 30 minit selepas kelas ini tamat. So jangan lambat-lambat, isikan dengan segera dan anda boleh simpan, boleh kumpul link sijil-sijil kelas Tuition Academy ini. Kita beri secara percuma saja Mr. Pei. Dan pelajar jangan lupa untuk ikuti kelas kita untuk minggu depan. Kita akan teruskan untuk tingkatan 4.3 iaitu haba pendam tentu bersama dengan Cikgu Faizah. Manakala untuk tingkatan 5 pula akan disambung oleh Cikgu, iaitu kita tajuk yang baru Mr. Pei. So minggu depan kita masuk tajuk yang baru iaitu tajuk yang kelima, chapter 5. Iaitu 5.1 Electronics. Okey, jadi ini adalah topik yang terakhir untuk bab 4. So anda boleh ikuti semula kelas-kelas yang sebelum ini, boleh tonton di channel saya ataupun channel Cikgu Pei untuk tingkatan 5, dan anda juga boleh tonton daripada portal Akademi YouTuber. Jadi jangan lupa layari www.academyyoutuber.com untuk ikuti kelas-kelas secara langsung ataupun kelas-kelas ulangan untuk subjek-subjek yang lain. So Mr. Pei, ada pesanan terakhir tak untuk pelajar untuk hari ini? Silakan Mr. Pei.
Okay. So thank you TVH, okay, dengan Anis kan, okay.
Yes.
So join kelas saya. So harap lebih ramai lagi lah, okay, boleh manfaat daripada kelas AYU. Bukan saja kelas saya, kelas Cikgu Hasita juga dan rakan-rakan AYU lain lah, okay. Semua yang kita buat ini sebenarnya untuk kamu semua, okay. So support dan manfaat daripada apa yang kita contributekan lah, okay. Thank you.
Okey, jadi itu saja daripada kami. Saya sebagai moderator ingin memohon maaf sekiranya ada apa-apa kekurangan sepanjang mengendalikan kelas pada petang ini, dan insya-Allah kita berjumpa lagi dalam kelas-kelas yang akan datang. So, salam sejahtera. Assalamualaikum dan jumpa lagi. Bye-bye semua.
dibawakan kepada anda oleh Akademi YouTuber.